I'm Kara Miller.
And I'm Rob Stoner.
And this is What If It Works? From the MIT Energy Initiative, this is What If It Works, a podcast looking at the energy solutions for climate change. I'm Kara Miller. You might know me from the public radio program Innovation Hub, which I hosted. I now write the Big Idea column for the Boston Globe.
And I'm Robert Stoner, the president of the Kendall Square Project and former director of the MIT Energy Initiative.
And today, a look at the epic challenge ahead, keeping the world's temperature from increasing by 2 degrees Celsius.
We need to really get on the road to net zero within the next 10 years. If that doesn't happen, then you can kiss 2 degrees goodbye.
We'll revisit an enormous environmental success story that rarely gets talked about, how the ozone layer was saved, which meant moving away from CFCs, chlorofluorocarbons. And back in the 1970s, CFCs were in all sorts of things.
Well, I was about 18 then, and I had in my medicine cabinet some underarm deodorant and hairspray, which, believe it or not, 75% of the global use at that time was for, quote, medicinal purposes, which were those purposes.
That's Susan Solomon, professor of atmospheric chemistry and climate science at MIT. And she was once an 18-year-old with CFC-filled hairspray and deodorant, but she would go on to become a pioneer in understanding the hole in the ozone layer. And she believes that much as we solved that crucial environmental problem, we can do it again, which we will get to. But if you rewind for a minute to the 1970s, scientists were only just starting to realize the huge impact that CFCs had.
The early concerns about ozone actually came from two scientists, Melina and Roland, who went on to share the Nobel Prize in chemistry for having done such a cool thing. And what they did was to point out that the chlorofluorocarbons, which contain chlorine, were being used in increasing amounts, and that chlorine had the potential to destroy ozone. So they did a little simple calculation and showed that. The key point was just these things live for 100 years. We're using more and more of them, so it's building up in the atmosphere. It's very dangerous.
CFCs had been an integral part of American life for decades at that point. In the 1930s, they were being used to cool things down in refrigerators and to cool us down using early air conditioners. In the 1970s, it became clear CFCs were building up in the atmosphere, which is when Sherry Rowland and Mario Molina started to wonder if that buildup had adverse effects, which, of course, it did. And pretty quickly, consumers got motivated to change.
Overwhelming numbers of Americans went to their medicine cabinets and threw that stuff away. So hairstyles changed, actually. That's one of the big reasons why the bouffant hairstyles of the 70s went away, which was really no big loss, I think. Suddenly, underarm deodorant became roll-on, which was advertised as saving the ozone layer. Get on the stick to save the ozone layer. That's
Really?
what people said, yeah.
Solomon, the author of the new book, Solvable, How We Healed the Earth and How We Can Do It Again, says consumers don't usually realize how incredibly powerful they are.
When you look at, for example, the closure of coal plants all around the country, many of them have been closed because the consumers demanded that they close. So it's quite possible for people to have a big influence. And, you know, I'm not saying we're going to have a 75% reduction in fossil fuel use that way, but even a few percent gets industry's attention because nowadays industries, you know, operate on the belief that they have to keep growing at some pace, and they become, you know, really concerned when they see a difference happening.
She believes we are rising to the occasion on climate change because the stakes are high, much as they were a half-century ago. She calls the ozone layer the world's signature environmental success story.
So what we have done is to basically phase out the bad chemicals that were causing it, yet we still have air conditioning, refrigeration, and all that happy stuff. So the concentrations of those molecules have dropped significantly. They do have those 100-year lifetimes, just as was predicted, 50 years ago. Amazing. But so there is still some left. But the ozone hole, for example, is starting to form later in the season, and it's smaller in the month of September.
Solomon says the evidence is unequivocal that the ozone layer is recovering. And if we hadn't chose to mostly phase out CFCs, we would be grappling with some terrible problems.
The world would be in deep, deep yogurt right now. I mean, the amount of ultraviolet light that would be reaching the Earth, causing already increased numbers of skin cancers, it would be astonishingly bad. So we really did something great. On top of that, the chlorofluorocarbons themselves are greenhouse gases. So phasing them out actually shaved off a chunk of global warming. Probably by 2050, it would be about a degree of global warming.
It's considerable, yeah.
Think about that. So it's very, very good that we got rid of this stuff.
But to phase out a class of chemicals or a technology, you have to change the corporate world. Chemical companies have to change what they sell, or fossil fuel companies if you want to fast forward to today. And that often is not easy. Indeed, the battles we've seen so far may be nothing compared to what's next. Here's Rob Stoner in conversation with Susan and me.
You talk about these refrigerants and how we found a different way, a different set of refrigerants that got us into a different problem, and now we're going to solve that problem. But at the end of that, the same chemical industry emerged. We didn't eliminate them. I'm wondering how that kind of situation contrasts with the climate situation where we have these fossil companies whose existence depends on this, and there isn't really an alternative fossil fuel that they can create that would allow them to continue. I mean, what do you think about that?
Yeah, that is a difference that is fundamental and very serious. I will point out that another issue where we did achieve a change is the use of lead in gasoline and paint. You know, the metal industries had a fairly big investment in producing the lead that went into those products, and they weren't going to be part of the solution. They were not part of the solution. They actually had to change, do something else with the lead. I'm not even sure what they do with it anymore. It's such dangerous stuff.
It wasn't pencils anymore.
Well, actually, one thing they could do is mine zinc instead, because zinc is not toxic in paints.
But that's encouraging because they did have to write off an asset.
Yeah, they had to write off a big asset. I mean, they owned mines that were lead mines. But, they were not on the scale, clearly, of the fossil fuel industry. The fossil fuel industry today is a $40 trillion industry. That's the value, roughly, of all of their mineral rights. They own mountaintops full of coal. They own the rights to, certain oil wells. They own offshore oil platforms, every one of which costs about $200 million. And I don't know how many they have. It's probably dozens. So they own a massive amount of mineral rights and infrastructure. It's worth a lot of money. What are they going to do with it is a very, very important question. So what they could do is carbon capture and storage is one thing, where you continue to burn the fossil fuels, but you put the carbon right back in the ground. That's right now too expensive to be contributing in the same way that some of the other things can contribute now. And one of the big issues is we need to really get on the road to net zero within the next 10 years. I mean, if that doesn't happen, then you can kiss 2 degrees goodbye. So we should be thinking about the longer term solutions that will help us in 20 years and 30 years to get all the way to net zero. But one of the big things we have to do in the next 10 years is get halfway there. And so, carbon capture and storage is a great research question. Maybe we'll have it ready in the longer term, but it's not going to contribute right now. So I would argue we do the things we can do right now. The other thing, of course, that the fossil fuel industry is interested in is, they know how to do a lot of things with methane. They could learn how to do a lot of things with hydrogen. A gas they can make out of the hydrocarbons that they have, because they have hydrogen in them. The other thing that they could do is make ammonia, which, again, has hydrogen. So all those options are on the table and are being thought about as to, whether these really are good solutions. How safe is it to make a lot of ammonia?
Yeah, that's hopeful.
An important question.
Many of them do refer to themselves as molecule companies now,
Right.
not necessarily fuel companies,
Right.
and so or energy companies.
We're not an oil company. We're an energy company. You hear that a lot, actually, which is, what it shows you is that they have understood that there's a time scale for this. What established that time scale? It's the consumers. And it's the fact that consumers realized that this issue was becoming personal, that it was actually perceptible that summers, for example, are hotter and heat waves are more severe. So these are my 3 Ps that I love to talk about. The issue is personal and perceptible. That gets us going. And we find practical solutions that gets us the rest of the way there. And so the practical solutions have also evolved tremendously. Solar has gotten much, much cheaper than it used to be. It's now, well cheaper than coal and even than gas, which is really quite amazing. And that's without subsidies in most of the country and most of the world, actually. So the technology forcing and steering that we did, when people demand change and governments do a little bit of investment in research and companies see that there's a economic opportunity, that steers technology in a certain direction. You put that together with the 3 Ps, and that's how we solve environmental problems, in my opinion.
So I just want to dive a little deeper into the fossil fuel question and companies. How much resistance is there? Because as you say, there's like all these sunk costs. We've already built these platforms, already drilled these wells. We spent a lot of money doing this, and we don't want to just abandon our investments. And how much is that, beyond petroleum? Like, are they actually going beyond something, to some other phase in their lives?
They're trying to figure out what that next phase is. And, I think one of the challenges they face is doing something at the same scale as what they're doing now. They think about getting into electricity generation. Okay, electricity generation is big scale. It's practiced everywhere, but it's not nearly as profitable. So they have also a big profitability problem that they have to, maybe at some level that leads to nefarious behavior and doing stuff they shouldn't do in Washington. But I think more insidiously, it leads to lethargy and a disinclination to do things and finding excuses, stuff we all do when we don't want to do something. We get something better to do.
Probably stuff we all do when we're making so much money doing something that's not that great that you kind of drag your feet to change what, like an individual might have the same behavior.
Yeah, so I see a lack of real vigor and commitment to changing on the part of those companies, if I can say that without offending too many of them. I don't know really what the answer to that is. They may no longer be able to function as companies that do what they're doing. And maybe they have to become different companies or smaller companies or break up and become companies that mine or do other things. Some of the things they do will persist. These are also very large chemical companies in many cases. One of the chemicals they produce is, fuel, but they also produce a lot of plastics, a lot of lubricants, a lot of other things we use throughout the economy. Those things will continue, probably. Substitutions can be found. So they do invest in those sorts of things. But I think the notion that they can become energy companies in a new energy economy, making solar panels and windmills, this is sort of I think, wrong. I don't think that's going to happen.
Yeah, and it's good for the public to understand and think about those things because it helps you to put into context how to view those claims. And I will say that some of those companies seem to be more genuine about changing than others. So I kind of hesitate to put them all in the same basket. There's clearly money to be made by the one or ones who figure out best what to do instead. And they sense that, and they're going after it. I mean, let's face it, we don't have a history of doing a lot of protection of industries that have become obsolete. We didn't protect, the buggy whip when the automobile was invented.
Right.
Because, that was a transition that had to happen.
That's
a little bit.
That are making things that are systemically important.
Yeah, well,
you don't need hairspray and deodorant to run the economy, but we've developed, for better or worse, an 8 billion person global economy that runs on these things, and simply withdrawing them is absolutely economically disastrous if it's done wrong.
Absolutely agree. Their best bet is probably carbon capture and storage, done in a genuine way. One of the problems we have right now is that a fair amount of that activity is actually using the CO2 then to frack, to get oil and gas out. So they pump it down and out comes oil and gas, but that means that also the CO2 comes pouring out as well. So they're not really putting the CO2 away. They're capturing it, but then they use it for something that, or you can put it in fizzy drinks. You put it in fizzy drinks, it ends up fizzing back out into the atmosphere. So, you're going to have to decide to really capture it. And a lot of them are not really on board with that yet because there is financial value in selling CO2.
So is the carbon capture that's happening initially that they're capturing what's coming from the initial drilling?
Yeah, no, well, from say, a power plant.
From a power plant, but then injecting that back into the ground to
produce more oil.
Produce more oil or natural gas or something. Got it.
Personally, I think it takes a village. I'm being totally honest with you. When you look at, for example, getting rid of DDT, it took Rachel Carson writing a book that woke people up. It took people realizing it was personal. This stuff could be in their bodies. It was perceptible. Robins were falling out of the sky. By the way, I remember I was a child back in the days of Rachel Carson, and I do remember finding dead robins on the lawn and saying, "Mom, what is this? Why are all these dead birds?" So the practical solutions were pick something else. But a lot of the action that happened was public interest, but also the involvement of EDF. The Environmental Defense Fund was actually founded because of DDT.
Oh, I didn't know that.
And what the Environmental Defense Fund sprung from a group of citizens who were meeting in living rooms of themselves and their friends and talking about the fact that there were all these dead birds and they wanted to stop the spraying of DDT. And so they started lawsuits against the spraying, against their town that was doing the spraying. So this was at the very local level. And what ended up happening was amazing. They didn't actually win those lawsuits. The judges would say, we have to study this, so you can't use it. We have an injunction against using it right now. And then, you know what happened? The towns figured out they could actually spray other stuff instead. And so they sprayed that other stuff. And so EDF learned how to win by losing and how to use the courts in the DDT story. And it's really quite amazing. And then they did it actually nationwide. And eventually they brought a citizen's petition in the state of Wisconsin to their Department of Natural Resources, which happened to be a state that had a law that said any group of citizens, or maybe even any citizen, can petition the state about something that's related to environmental actions by the state. So that was the question. Is it okay for the state to do this? And they actually got so much public attention that it was a big part of the why DDT was ultimately banned in this country.
So that's encouraging because we're having all of these sorts of legal disputes over CO2 emissions, and we're losing those too. So
it takes a village.
Victory's at hand.
It takes a village to raise the awareness, to raise the questions of what else could be done. That's really what EDF was doing with the DDT lawsuits. People do a lot of things because they're used to doing them, and consumer groups can force change. Same thing is happening right now with permitting for electric companies. So it's turning out to be very difficult for companies to get permits to install as much solar as we would like to install. It's not anything nefarious. It's just that the people who oversee how to keep the electricity flowing are used to doing the things they know how to do.
And they're very concerned with reliability.
Yeah. And of course they should be. That's great because, we don't want the lights coming on and off. So they do what they know how to do. And that has to change. That's a big change. By the way, the same thing's happening in China, as I'm sure you probably know. It's the provinces versus the federal government in China, but it's the same thing. Yeah. The locals want to do what they know how to do, and there needs to be some level of pressure to get them to change. That pressure could come from the federal government, could come from people, could come from the courts. There's lots of ways to, like I said, it takes a village to solve these problems.
For many years, and this will sound bizarre to our listeners, I led a program here at the request of the Chinese government to bring state leaders to MIT to teach them about the technology options available to them and excellent policy, which is sort of laughable looking back on it. And it was actually quite a good program. We learned a lot, but it's exactly what you're saying. It was get those provincial guys in there and train them. They loved it.
Yeah, and then they went home and did a better job.
Yeah, exactly.
So, Susan, the current expectation of sea level rise, my understanding is based only on thermal expansion, does not take other things into account. Do you think we might be underestimating how bad things might get?
Actually, we do take other things into account, and those other things are small glaciers, and of course the great ice sheets of Greenland and Antarctica. I'm not sure I know the latest and greatest wisdom on that, but I think the estimates are that it's about 50-50 thermal expansion and all that other stuff. Because, we have lost a massive amount of ice on land. So it's the ice that melts on land and gets into the water that adds to the fact that the thermal expansion is just the simple fact that it's water, and as you heat it up, it expands. I mean, if you've ever made a pot of tea, you noticed what happens in your tea kettle. So it's fundamentally that same process. That is the easier part to calculate. It is true that getting in an accurate way the loss of the great ice sheets of Greenland and Antarctica is a tough problem. We do better probably on the small glaciers. So that's where a big uncertainty lies, but it's not the case that we ignore that when we give you a number. So take all that together, what we think we're going to see by the end of this century is something on the order of 1 meter of sea level rise, so about three and some feet.
How would that affect you if you were in a coastal city around the, what does that mean? What does a few feet mean?
It means you should look at the elevation of property that you own and ask yourself, how long do I want to keep this property, and decide whether you think you're safe enough. That's fundamentally where we're at.
Yeah.
It's a challenging issue. And of course, there are whole parts of the world that are definitely going to go underwater. A big chunk of Florida will be underwater. The state of Florida, I think the highest point in the state of Florida, Rob, you might know this answer, it's only a few feet. It's not a lot.
Really?
Yeah, Florida is very low.
So like 3-4 feet is really going to change things in Florida.
It will change the entire coastline. It doesn't get everything, but it gets a big chunk of Florida.
It's funny to see in Florida people building houses on stilts with the idea that, I'm going to survive the sea level rise. Of course, they're not going to have any neighbors. So I don't know why.
Well, maybe that's good. I like to live alone. I don't know.
Even more exclusive.
In the middle of BC.
Yeah.
What are the indicators that you're looking for that will tell you if things are, progressing more rapidly than you think or deviating from what you anticipate?
I'm concerned about heavy rainfall and flooding, which seems to be on the rise. It is on the rise. We expect that to some extent based on the climate models. But the bad thing about rainfall is that not only do you get a change in the average amount, but you actually get a change in the shape of the distribution of rainfall such that you're getting more of the heavy stuff. And that's true pretty much everywhere. In temperature, that's not quite how it is. You shift the average, which in turn means that the hottest temperatures are hotter than they used to be, and you set new records and you have new heat waves, but it keeps the same shape. It just moves over a little bit. So we've seen that, in many, many different measurements confirm that. But rainfall, I think, is a lot more uncertain how heavy it's really going to get. It's projected to get heavier, but I don't think we know how much heavier the heavy rainfall will be. And that worries me. And things like, what it's going to do with hurricanes. We don't have an infrastructure built to withstand the kind of changes we're going to see. We're already seeing bad stuff happening.
There was recently very heavy rain in Florida that caused a lot of flooding. And the governor, as he's wont to do, came out and, of course, denied that this had anything to do with climate change. But it was emblematic to me of a problem that you have when you're discussing this with people. And people who should not say such things will often attribute one storm or another, or a tree falling down to climate change. And I mean, it sounds absurd even to me. And so we're sort of stuck in this world where, in order to make the case that it's perceptible, one of your 3 Ps, we've got to somehow claim those events for climate. And how do you do that? I mean, it's a statistical game.
Yeah, but people again are smarter than I think we give them credit for. Yes, these are familiar phenomena in the sense that we've seen heavy rainfall before. But the idea that not only is it heavier than we ever had, it's also happening more often, is actually not that hard for people to get.
Are we plotting graphs of these things? I mean,
Sure.
so that the statistics are really excitable? Where can we find them?
I mean, they're certainly in the IPCC reports. You can certainly find them there.
The IPCC. Tell us more about the IPCC. You've been involved with that for a long time.
The Intergovernmental Panel on Climate Change is an international group that provides assessments of the state of the science and of the impacts and of the policy options. There's 3 different groups. And I was the co-chair of the science panel in 2007. And we provide those assessments to the UN and also to the world. So it's a very interesting process. You get to see how the negotiators work. The same people who negotiate the treaties are the ones who discuss the science with you. It's often accused of being sort of hijacked by the negotiators. I can tell you that is not the case. Scientific assessment is so valuable, not only for the diplomats, but also for the public, because you should look at those if you can. You don't have to go through the big underlying reports that are so thick, but you can look at the highlights and ask yourself, how did this get agreed by 113 governments if it's not true? Generally, that it is true, because that's what has to happen to get it agreed. We're at the table, the Russians are at the table, the Europeans, the developing countries, everybody. It's quite a process.
The IPCC did something in its more recent assessment of climate science, of showing what has to happen in emissions over the course of the century in order to achieve 1.5 or 2 degree temperature rise on average. And what they showed was that we have to remove, they labeled as removals of CO2 from the atmosphere in order to achieve those things. And it was clear why they did it. I mean, they want to make sure you understand. I mean, if we continue emitting at the economic rate that we're continuing to emit, then we're going to have to pull CO2 out of the atmosphere to hit these numbers. But it implied that we could in some way. To see that on a page, make you think, oh, well, I'm a diplomat. I'm going to, vote in favor of having removals. And it was something like 10 gigatons a year throughout much of the middle of the century in order to hit those numbers. What do you think about CO2 removal technology? Is that really a practical option?
Well, we talked about this quite a bit earlier. It's not going to be practical in the next 10 years. So it gets back to, if you decide that you're going to continue to use fossil fuels, you're taking on sort of a carbon debt that you then have to get rid of if you want to, for example, keep the temperature from going above 1.5 degrees. Now, maybe you're going to decide, 2 degrees is okay. Then you don't have to remove it. Those are the kinds of decisions that are going to have to be made. And they present those cases not to say this is the way to go or this is the most likely pathway. They present those cases just to show what would happen if you chose this pathway.
Right.
But they have a bunch of different pathways.
In fact, so the implication isn't that you can do it. This is an option that's available to you. It's that if you don't, then you need a miracle to occur, and this is how big the miracle is.
Well, or you need to figure out how you're going to adapt to a hotter temperature.
Adaptation, that's another really important topic, because in large part, the problem with climate change is not that 2 degrees warmer is intolerable to us as people, or that more rain is intolerable to us as people. We can swim and we can find other places to live. It's that it's too fast. We can't adapt, and the ecosystem can't adapt, and other species with less technological capacity than us can't adapt for sure. Something I think about a lot, I haven't quite bottomed out on it, is how we should think about allocating resources toward mitigating climate change, trying to reduce emissions, and just saying, oh my goodness, we better put more money into adaptation, building dikes, relocating populations. How do you think about that? Are you not prepared to give up yet?
Oh, give up what? I mean, give up emission mitigation? Definitely not.
Yeah.
You have to view it as a carbon debt that you're going to have to pay back. So it's like a balloon mortgage. I mean, I personally don't like that. So I am in favor of going all out right now on the things we know how to do and get our carbon emissions down. I think we can hit 50% reduction by 2035, maybe.
What would be like the top two things you would push, like let's say the U.S. government to do?
Yeah, I mean, we're already doing them, frankly, because the Infrastructure Act and the Inflation Reduction Act have a lot of stuff in there that if we do it effectively, will drive down our carbon emissions a lot. So it's electric vehicles, certainly. One of the problems there is not building out enough charging systems. We're going to have to really get going on that, but we could if we chose to. The other thing is solving these problems of connecting the solar that we know we need to connect to the grid and also wind. There's issues of supply chains that are affecting the build out of wind. We need to solve those problems, but they are solvable. They are things we could do right now.
So this is a really important point you're making, because the cheapest thing we can do is simply not to emit CO2, and then we don't have to clean it up. The next cheapest thing is to quickly develop mitigative technologies like electrification of cars that costs a certain amount and certainly affects our economy, maybe modestly negatively. But the most expensive thing we can do is try to adapt in the future because we haven't dealt with those things. I mean, moving New York City is a lot more expensive than putting in some charge points for electric cars.
Moving Miami, for example, which we already talked about, is going to be real expensive.
One thing we have not talked about is the geoengineering piece of it. I don't know how much you've thought about this. This idea of like maybe injecting stuff into the atmosphere. How much have you thought about it? Where's your head on that?
I've thought about it quite a bit.
Yeah.
Because many of those schemes involve injecting something into the stratosphere, which I know a fair amount about. They are zany. I mean, that's the only word I can think of for them, really. It's
so refreshing to hear that.
It's not that we don't have the potential to do those things, but, do we really want to put sulfur in the stratosphere, which is what they're talking about? It's be like little volcanoes going all the time. That actually, we know from stratospheric work, would destroy the ozone layer. It would be detrimental to the ozone layer. So it's not going to completely destroy it, but it would give us some ozone loss. Do we really want to take an action to set back the most successful environmental protocol we've ever had? But more important than that, there are several things that are wrong about it. Let me start with one of the big ones for me. And that is that when you talk about it as if it were just a scientific problem, you're basically normalizing the issue. You're making it something that the public is going to hear saying, oh, scientists think they can solve this. Isn't that great? So now I don't have to worry about it. I mean, it's that lethargy problem that we talked about before. It's a perfect excuse for complete lethargy. Let the scientists figure it out. And I have a serious question here. Is it really the proper role of science to be normalizing something that we don't know how to govern? The real problem is there's no reasonable governance structure for this. Who's going to be in charge of putting all that sulfur in the stratosphere, and how are they going to set that thermostat for the whole world? Who's going to decide? If it's Russia, they might like to be quite a lot warmer. They're a pretty cold country. Make Siberia, a place where you could grow a lot more wheat. That might sound real good to them. It's not going to be any individual country, but they have the capacity to do it, and so do individuals. I have nothing against him, but is it Elon Musk who's going to set the thermostat for the whole world? I mean, governance is a big, big issue, and it's not being talked about. Somehow the idea is, well, we'll figure out the technology first, and then we'll worry about the governance. I think it should be the other way around. Let's actually have a serious discussion about how we would govern this thing if it was possible. It's a little bit like COVID. People are now very upset over the idea that really we don't have enough biosafety in the world's labs. So are we going to just keep doing biological research that might be dangerous without having a governance structure that actually works at the international level for dangerous things? So now there's beginning to be a little discussion around international governance of that kind of research. I think you have to ask those governance questions in the world that we have today. So geoengineering worries me that way. The other problems with it, scientific ones, are you keep emitting the carbon, which means you keep acidifying the ocean. And the dangers of that are big. You also change the rainfall patterns. And maybe it's only one country that suddenly, maybe it's India, doesn't get the monsoon rains anymore. And so their agricultural system is completely upended. Is that going to be okay? Personally, I don't think it's okay. Another problem is, how do you stop? Once you start, if you stop, you will have a response in the climate system. And there's some evidence to suggest that right now, we've sort of done that experiment. When you look at how hot temperatures are for the last year and a half or so, they're unbelievably hot, much hotter than we expected. Yes, it's been an El Nino, but it isn't that extreme of an El Nino that it should have produced this kind of global, massive temperature rise. There's some evidence to suggest, I'm not saying this is proven yet, but it's being talked about, that the reason it happened is that shipping fuels got cleaned up. So the fuels for boats, there's a lot of cargo that gets transferred by ship nowadays. That stuff used to have very sulfurous fuels that it burned, which put particles in the atmosphere, not as high up as the stratosphere, but enough to make clouds. And that has gone way down because the shipping industry decided to clean up their fuel. Well, it's great that they cleaned up their fuel, but it meant that the particles went away, and that may be part of what's happening. In fact, there's papers that suggest that is the story. I'm not sure I believe it yet, but it's certainly a viable theory.
But the notion being you take the geoengineering away, and who knows where
you
are.
You are going to get warmer. How much warmer? Is it going to give you a serious thermal shock and all kinds of other shocks like have happened in the last 2 years? I mean, it's been bad. Heat waves have killed people. Right now, heat waves are killing people. Last summer, heat waves killed people. Heavy rainfall has caused a tremendous amount of damage and death. It goes on and on. The world doesn't adapt easily to quick changes. So once you start, you're gonna have to keep going. And boy, is it messy. And with no international governance structure, are you kidding me?
My sense is that this topic, though, of geoengineering has gone from being a taboo 10 years ago to one where people are trying to do the experiments. They're talking about it a lot more than they used to. It's almost socially acceptable. That's kind of scary.
That is this creeping normalization that I just talked about, and I think it should not have happened. I think more scientists should have spoken out as I do, and I wasn't thinking that clearly about it either, to be honest with you, 5 years ago, and said, let's talk governance first and technology second, because, boy, we don't want to invent something that's that dangerous.
I think the media is also kind of fascinated by it. I mean, I think partially it seems like, wow, could this be the solution? What an amazing sort of science fiction come to light.
There's some charismatic scientists who I shall not name wandering around talking about this stuff, starting companies that do this kind of stuff. And I would agree with you that this should not be going on.
Governance should happen first. And if the governance system is worked out and it's all clear-cut, how you govern the research and also how you govern the implementation, then we're ready to actually do the research. But we're doing the research like cowboys in the Wild, Wild West. And so the public is getting a message that is normalizing the conversation, and that is not good.
Yeah.
So finally, you've written a book called Solvable, which seems like a really optimistic title for a tough subject. And we're in a country and in a world where people have a very wide variety of views about climate change, what, if anything, we should do about it. Politicians are all over the map on that kind of thing. Given what we've talked about, what makes you think this is solvable?
I really believe we're right on the cusp of succeeding with this problem. We are right on the inflection point. And the reason is that basically when I look at environmental issue after environmental issue, I see the same factors that characterize when we start to achieve success. It's the public being engaged and interested and feeling that it's personal. The technology steering going on that makes solutions practical. We've seen all of that. And it's not just in this country, I would say. I mean, you're quite right to point out that we have a deeply divided nation in many ways. On the other hand, amazingly, doing something good about climate change, doing actions to mitigate, to help climate change not be as bad, is popular in this country when people do polls. So people would like to see that happen. People are in favor of clean energy. Mm-hmm. And it's getting cheap enough that it's overtaken a lot of the other energy. I mean, you can bang on the table all you want and say, I'm going to bring back coal. No one's going to bring back coal. It's uneconomic. It's on the way out. We've seen that for years. The number of coal plants has decreased dramatically, and it's happening all around the world. So economics and public interest and enough of a push to move those things along is exactly what we need. We are going to have to change a big chunk of our infrastructure, but there's more and more evidence that we can do that relatively easily. People used to say, oh, the grid, it's too hard. We'll never change the grid so that it can distribute energy so easily. We now have carbon fiber wires that we can put in place of the existing wires that will be much more efficient and will move that energy around. The only thing stopping us from doing it is it's not that expensive to replace the wiring, and it's old and falling apart anyway. That's why the Infrastructure Act and the Inflation Reduction Act were so popular, because they incentivize doing a lot of the right stuff. And in other countries, it will happen too. If we're not in the forefront, maybe it's going to be the Europeans this time. We were in the forefront on solving ozone depletion. It's fine with me if somebody else carries the heavy water on this one. And to a large extent, they have been carrying more water than we have. The reason is that they are less fossil rich than we are. Mm. It's the fossil rich countries, and that is mainly China and the United States, that have a big job to do. But, they're not the only consumers in the world, and the pressure on industry is enormous to be able to sell not only in the U.S., but to sell overseas too. That's why all the car companies want to go electric, because they want to make cars they can sell in Europe too. And, Norway, for example, is already almost all electric vehicles. It can be done. Norway's not a very easy country to get around in either. They have fjords and mountains and, and yet it's all good, so we can do it.
It feels to me like we're going through your 3 Ps in phases. We've got the perceptible, personal, and I think we really are moving into the practical now as these things become affordable and we figure out how to put them together.
And that's what's happened in every single past problem, whether you talk about lead and paint, lead and gas, DDT, the ozone layer, smog, you name it, we did it. And we moved some big industries around, by the way.
Yeah.
DDT moved the farming industry out of its comfort zone. Smog moved the automobile industry out of its comfort zone. And the automobile industry was as big as the U.S. fossil fuel industry in those days.
Susan Solomon is professor of atmospheric chemistry and climate science at MIT. Her new book is Solvable: How We Healed the Earth and How We Can Do It Again. Susan Solomon, thank you so much. This is great.
Thank you. Thanks for having me.
What If It Works is a production of the MIT Energy Initiative. If you like the show, please leave us a review or invite a friend to listen. And remember to subscribe on Apple Podcasts, Spotify, or wherever you get your podcasts. You can find an archive of every episode, all of our show notes, and a lot more at energy.mit.edu/podcasts. And you can learn more about the work of the Energy Initiative and the energy transition at energy.mit.edu. Our original podcast artwork is by Zeitler Design. Special thanks to all of the people at Mighty and MIT who make this show possible. I'm Kara Miller.
And I'm Rob Stoner.
Thanks for listening.